right? This is all about that operators, and we have one thing, bitwise operators also. Bitwise operators are the lengthy thing. Simply I can give a overview of the bitwise operators, how it perform. Bitwise operators are nothing but wait a minute. Right. Bitwise operators, in this we have the different bitwise operators, and, or, not, and XOR, left shift, right shift. Like this we have the different bitwise operators. And why it is easy is, suppose you have to working on a bit manipulation, then it will help to you. The thing is same, but the comparison is on bits. Suppose I have the one number 5 and I am performing 5 and 1. Okay, 5 and 1. 5 is one integer, 1 is one integer, but I am performing bitwise and between the integers. That means my 5 will be the, my 5 binary will be the 101. It is the binary conversion or the binary value for the 5, and 1 binary value of 1 will be the 001. Okay, then the result performing the 5 and 1, 5 and 1, it will be the, suppose 1 1, if the both the inputs are true, it will be the true, that means 0, or else it will be the false. 1 0, one of the input is true, it will be the result 0 0 1, that means both the bits are the 1 only, resultant bit 1, or else it will be the 0 only. Okay, in the bitwise and same like a logical and, but the difference is logical and performs on a expressions, bitwise and performs on a bits. Both the inputs are 1 only, it will be the 1. If one of the input will be the 0, it will be the 0. Then 5 or 1, if you check same for the 5 or 1, right? Okay, already checked the 5 and 1 here, right? So we'll simply five or 1, right? 5 or 1, that means one of the input will be the 1, then the output bit will also 1. If the both the inputs will be the 0 only, the output will be the 0, output bit will be the 0, right? If one of the input bit will be the 1, then it will be the 1 only. Okay, it is the OR operation. But when you are performing the bitwise AND, but the result will be print like a integer only. Why 101 is the, again you are converted to the decimal, it will print 5. 1001, it will returns the 1, 5 and 1 means the same like 5 XOR 1. 5 XOR 1 means XOR operation, what it performs is, if both the inputs are not same, then output bit will be the 1. That means if here 1 and 0 are the not same, this input bit not same, so 1. But here 0 and 0, so it will be the 0. Here also the same, both are the same bits, so here it will be the 0, right? And 100 means 4 will be the value, right? Like the same way in the shift of XOR operation we completed. Not, we'll see that not also you can performing on a single thing. Not operation you can performing on a single thing. Not, we'll check with the not. how can we deal this is not, suppose I am performing the not of 5. Not of 5. That means already we know the 5 binary value 101, right? When you perform not, every bit will be the vice versa. If it will be the 1, then it will be the 0. It is 0, 1. It will be the 1, then it will be the 0. The result is 0, 1, 0 means 2. 0, 1, 0 means 2. You have to know that binary conversion, decimal to binary, binary to decimal. That's the thing, right? And we have to see that left shift and right shift. Okay, suppose I am writing like 5 left shift of 2. It will be the right shift, right? 5 right shift of 2. That means you already know the 5 binary value, right? What is the 5 binary value? 101. That means 101 performing right shift of 2. That means right shift to the 2 bits. That means here 1 shifted to here, 0 shifted to 1 place, 1 shifted to 3 place. That means you are writing like simply 00101. Okay, or else this is the result. That means you are replacing these two things. This will be the result. It will be the 1 when you are performing this result. Why? Because this is the last bit. You have the MSB and LSB are the two things. You have the MSB and LSB. It will be the LSB, least significant bit. That means you are not move this one. So this thing, where is 101? This 0 will be replaced to here. That means I am with the 010, and again I am convert to here. 1 bit was shifted, but after that it will be the better execution will be the, I can show it in a paint or one thing. Wait, how it will be the thing. Right. Suppose I have a 5 right shifted 2, right? That means I already know the 5 binary value 101, right? 5 binary value 101, but I am shifting the right shift of 2. That means this 101, this 101, this one shifted to here. Okay, this one shifted to here. Okay, and 0 shifted to here, and again 1 shifted to 0's place. That means shifting here takes. Okay, 1. That means when you are performing the right shift, blindly follow the one thing. How many bits you are shifted, that much bits you have to cancel it and place the zeros in front of that. Okay, that means if you are performing the right shift, if suppose you are dealing with the 5 right shift of 3, then it means 5 right shift of 3 means you have the 101 as a binary value. So remove these 3 bits, last 3 bits, and add the zeros. Then this result will be the 0. Then result will be the 0. Why? Because we are shifting the zeros, right? It's the same way here also. When you are have the 101 right shift of 2, that means cancelling these last 2 bits and adding the zeros in front of that. That means it will become 001. The result will be the 1. Okay, you have to understand that thing. Suppose I have the another thing of 7 right shift of 3. Okay, the binary value of 7 is 111. Okay, 111. I have to cancel the last 3 bits and replace the 0. If you can place n number of zeros in the left side, but you are not placing beyond this LSB, least significant bit. Okay, you can place n number of zeros in front of the MSB. Okay, it's not an issue, but you are not placing this any number of zeros. Okay, if you are performing here right shift, then it will become all zeros. And one example, 8 less than 2 or right shift of 2. That means 8 binary value will be the 1000. I am performing 2, right? So last 2 bits, these 2 bits will be the cancel, and you have to add zeros in front of that. Okay? Zeros. That zeros will be the that zeros will be the 0 0 1 0, then it result will be the 2, right? You understand that one. The same way, left shift 5 left shift of 2, that means you have to perform the left shift operation to this side. I have the 101 left shift of 2, then that means you have to place zeros at the right. 101 00 101 00. The result will be the 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 16, 4, 20. This result will be the 20. Okay, that means you have to understand the thing. When you are performing the right shift, you have to place the zeros in the MSB side. When you are performing the left shift, you have to place at the end. Okay, and converting to the integer. This is about the bitwise operators. I have to give the entire overview. Now we will discuss that conditional statements. We have the different types of conditional statements, and different types means we have the if, else, switch case also, and we will see that one, right? And why we need that conditional statements? Because first, in the normal real world entity, why we need it? Suppose when you are ordering something in a Swiggy or anything, they are applicable some coupons to you. When they can applicable, if you are purchasing some amount of money, then only they will applicable that coupons. That means when you are meeting the particular requirement or particular entity, then only you have to execute something or you have to perform something. This conditional statements helps to you. Conditional statement helps to work on a particular conditions. When the particular statement true only you have to execute, then it will be the result, right? We have the different things, conditional statements. In the conditional statement, the first one is the if. If statement. The if statement basically runs when the condition true only. When you are writing the if block, the condition true only, the if block will execute. Okay. And another thing, if else. If else, that means you are, when the condition true, what you have to execute. If the condition false, what you have to execute. That means two blocks only. And one thing, if, else if, else. That means we are called it as a else if ladder. Okay. If, else if, else. That means you have a n number of conditions. You have the n number of conditions. That means else if will be helps to you, right? And another thing will be the nested if. Nested if. That means if you write one if inside one if, then it will call as a nested if. And another one will be the switch case, right? Switch case. Okay, right. We'll see these entire things with examples, then it will be easily understand to you what is the if and all, right? Okay. It is a basic one class we are created. In this, suppose I want to check one number is even or odd. I want to check one number is even or odd, or else suppose I want to check one number is positive. Simply I am taking a equals to 5 into a equals to 5. I want to check this a is positive or negative, right? Simply how can I check? Normally sys out. How can you say it is positive? If the a is greater than 0, this statement will be the true, then only I can say a is positive. But I have to print a is positive as a text. If you print like this, it will return true. You can achieve that, but you have to print something or you have to execute something, right? Suppose I am writing like if syntax. It is a syntax. Okay, we'll see what is the syntax of if. If condition block of statements. Okay, if condition block of statements, it will be the entire syntax, right? The same way I have to check it is a positive or not. If a greater than 0, that means if this condition true only, my if block will be the execute. Okay, if it will true, I have to print like or I have to add a equals to a plus 5. That means I am adding another 5 to the positive value. If it was positive, then only I can add, right? Sys out, then I can print that a. Okay, if a is positive, I can add 5 to the a and I will print that, right? Then my result will be the 10. Why? Already my a value will be the 5. If a is positive, I can add the another thing because of that. Okay, this statement is true and this statement is false. Okay, right. Suppose I want to check, this is the if. Normally if you can perform n number of statements, but if the if block has to execute, the mustly this condition has to be true. If the condition true only, it will perform. Okay, right. In the same way I can go with the another thing. If int also, okay, I'll check the even number program for the if else one. Here I can go with the positive. Simply I can print a plus is positive. A plus is positive. Okay, simply if I'll go with the another one, if and else, I am checking the even number program. How can I tell a number is an even? If the remainder, when you perform division operation with a 2, the remainder will be the 0, then only I can say my a number is even. So because of that, a modulus 2. If I perform this, the entire result will return the value, right? Equals to 0, a mod 2 equals to 0. That means the number is even, right? The number is even. And else, right? In the else case, system dot sys out, or else it will be the odd. Observe the thing. Now this entire thing will be the one pair. That means in these two statements, only one block will be the execute, not two block. This if is different, this two pair is different. Why? Because in the two things, only one will be the execute. If you are writing like n number of ifs, every statement will check. If you are writing like this, if the statement this one is false, it will return the entire final thing, right? You can understand when the else if you can write, then it will understand to you. If suppose if I write like this, it will be the odd will print, right? Why? Because 5 is odd. First you will print 10 is positive. Okay, it will print even. Why? A value changes, right? A value changes to 10. 10 modulus 2. then it will be the even. Because of that, I cannot perform here anything, then it will return the odd. 5 is positive, odd. 5 is positive and odd, right? Right? This is the if else. That means you can write when the condition meets, you can perform some task. If condition not meets, you have to perform some task. Then it will be the if else, right? In the same way, okay, you understand the if and if else, right? Control question mark. Suppose this statement also comment it. I am taking the 3 numbers, int b equals to c, okay, b equals to 3, int c equals to 10. Okay, I want to check which is the highest one, which is the second highest one, which is the third highest one. That means among greatest among the 3, second greatest among the 3, least one, right? Here I can meet the different. Suppose I want to check A is greater. A is the first greater. What is the criteria? A is greater than B and A is greater than C. A is greater than B and A is greater than C. Okay, right. If A is greater than B and A is greater than C, wait a minute. Okay. If the both the statements will true, that means which one is greater? A is greater, right? If the both the statement true, that means A is greater. I am writing like A is greater. A is greater. If this statement fails means what you can decide? If the statement fails means we can decide A is not greater. A is not greater among the 3. Okay, A is not greater among the 3. Next, if you want to check B is greater among the 3, then okay. Else if I want to check B is greater among the 3, that means B greater than A I have to check, also B greater than C I have to check. If B is greater than A and B is greater than C only, I can definitely tell B is greatest among the 3, right? B is greatest among the 3. See out. B is greater. Okay. B is greater. Right. If this statement is also fails means B is also not greater. Okay. This statement fails means B is also not greater. Right. If I go with the else, if A is not greater, B is not greater means then C will be the greater, right? If A is not greater and C is not greater, B is not greater, then in the final C will be the greater one. We have the only 3, we are checking the 2, then we can decide which C is the greater, right? What you have to observe is if you are using the if and the else if, you can write the condition, in the else you not write the condition. That means else is the final executing block in the conditional statements. Okay, right. C is greater. Okay, fine. But I am writing this condition for your understanding, but I am writing the best condition here. Why? Because this condition means what you are telling here. If A greater than B and A greater than C means A is not greater. You are confirmed with that, right? A is not greater means the greater exists between B and C, right? The greater exists between B and C. Then I can simply write this. I have to check which one is greater, right? I can simply check this, which one is greater, right? B is greater than C or B is greater than, if the statement true, then B is greater. If the statement fails, C is greater. Why I am checking the redundancy of the A again? You understand that question? In before, I have this one. In before, I have write like this. Here I am checking again B greater than A. Why? What is the necessity for that? By this statement, I am conclude that A is not greater. Then my greater will be exist between B and C. Then there is no need to check again the A, right? So I have to compare these two, B and C. B and C, then it will print, right? Okay, first we'll check with that one, and also again we'll go with this one. And I am running this. Which one is here? C is greater, right? Okay, the same way I can go with this one. Okay, this execute means B is greater, B will be the greater, right? Okay, 15. Then you can decide. B is greater, and I am changing this condition to the B greater than C. B is greater. Both the conditions work fine, right? Suppose if I write here also if I write here also if, then my output will be if A is greater also, A is greater and C is greater. If A is greater, suppose I am writing A is 20, then my output will be the A is greater, okay? Or else I am using like A equals to 2 only, then it will print, suppose if I write like this, we will observe the output. What it print? A is greater and B is greater. Why? In this condition, we have to check this one. A is greater among the three, right? In this condition, we are writing the if, not else if. That means this if is different, this is different, not in a pair manner. Okay? If you are writing else if means, if the first condition fails only, it will enter to the else if condition. If first condition true, then it will not enter to the else if condition. That is the difference between when you are dealing with the ifs and the else if. When you are going with the if and else if ladder, if the first condition falls only, it will enter to the else if condition or checks the else if condition. If the first condition you can prove, then it will not check the else if and all and else. If you are writing n number of ifs, if checks the every condition. It checks the every condition. That is the thing with the if and else if. When you are dealing with the if, it will check the every condition. If you are dealing with the else if the first if condition will the fails only, it will check the else if condition, right? It is the thing. And next we'll see with the what it is nested if conditions, right? Here we are simply checking the which one is greater, right? But I am printing like A is the first greater, B is the second greater, C is the third greater. That means I have to check the hierarchy, which one is the order. Suppose A is, this statement true means A is first greater. A is first greater. Then this statement true means A is first greater. In this, I have to check which is the second greatest. The second greatest lies between B and C, right? The second greatest lies between B and C. So I can simply write if B greater than C. If B greater than C means, this statement true means B is the second greater, B is the second greater, and you can simply write C is the least one. C is the least one. C is least, right? In the else condition, in the else, you can write the statement fails means, C will be the greater, right? The statement fails means C will be the second highest, B will be the least. C will be the second greater, B will be the least, right? In the same way, here also, if B is greater means second greater lies between A and C. So you can compare A and C. If this statement is true, A is the second greater, C is the least, C is the second greater, A is the least. If else block execute means C is the greater, then the second greater lies between A and B. A and B. A is second greater, B is least, and A, B, right? A is second greater. So B is second greater, A is least. Understand? This is the nested if. That means you are writing one if inside the another if. If you observe here, I have the outer if. This condition true only, this statement will be the execute. If this statement is false, then it will not execute this two, right? Okay. You have the true three values A, B, C, right? A equals to 20, B equals to 15, C equals to 10. What will be the highest value? A is the highest, first highest, B is the second highest, C is the third highest. I can change to this one. Then A will be the least, B will be the first highest, C will be the second highest, right? We'll check it, we'll getting the same output or not. B is the greater, C is the second greater, A is the least, right? This is the nested if, what we are discussed. Nested if means if you are dealing ifs under the one if, okay? This is a hierarchy. You can write n number of ifs. If you can write if inside this one also, you can write another if like this. You can write n number of ifs inside them. Clear? This is the nested if, right? Next we'll check with the switch case. Switch case also the same like else if ladder, but the difference is one thing. Based on one expression, you can check the n number of cases. One expression for the single expression. Here the expression will be the different, but for the single expression you can check. We'll check with the one switch case example. Then you can easily understand when you can use the switch and all. Right. Today's session we are end up with the switch. Let's we discuss with the switch. Suppose I have a ch, int ch as a value, or ch1 as a value, anything. Ch as a value, ch1 as a value with a 5. First we'll see the syntax of the switch, then we can easily understand. In the syntax, the switch you can write like a switch of expression, switch of expression, and block of statement. In the block of statements also you can write the cases. Case 1, block of case 1. Okay, block of case 1. And also you have to must mention the break for every case. Every case you have to mention the break, right? And case 2. Like this you can write n number of cases. But every case you have to write break. If you are not write the break, what will be happen we'll see. Case n, like this you can write n number of cases. Case n, and you can write break for the case n also. And the final one will be the default. Default means you have to execute default case like a else. Like a else you can write, and a default block. Right. We'll check how it will be the. This is the thing. I'll comment it. Right. We all knows that weeks, right? 0, 1, 2, 3 like that. 0 will be the Sunday, 1 will be the Monday, 2 will be the Tuesday. Like that we will check if we are giving the value of a 0, then it will print the Sunday. If we are giving the value of 1, you can write that Monday. Like that you can work on a switch case. Right. switch of ch. My expression here is ch. That means this entire thing, right? And case 1, 1. Okay, case 1, 1. If 1 means I can print sysout of Sunday. Okay, sysout of Sunday. Okay, we'll go with that. The same way, case 2, control C, control V, case 2. Okay, case 2, if 1, it will be the Monday. The same way I can write the default one also. Default one. In the default case, it will be the sysout I can write enter value between 1 to 7. 1 to 7, right? And we'll see that running it once. I am giving the 5, then it will print the enter value between 1 to 7. I'll check with the 1 first. I'm writing the not all the cases, right? Because of Sunday it will print, right? Okay. You can write n number of cases. If you case 1, if I go with the case 2, okay, if I go with the case 2, then Monday, if I not entering the break, what will be happened is it will go with the break will find. Suppose I am entering 1 here, 1 here. Suppose if I write like here, I can change the case, or else I can simply use 1 here, then I can write it. It will print Sunday and Monday. Sunday and Monday, but it has to be complete with the Sunday only, but it will print Monday also. Why? The case will be the execute completion of the all. Okay, finding the break. If you are not finding the break, it will execute the default one also. Okay, cases will help to you. Cases will help to you performing like this task. Based on one single expression, you have to execute something. Then it will help to you. I can write case 3. Control C. Case 3. The case values not will be the same. The case value, everything will be the different. Here you can use 1, then you are not 1 again. Not use the 1 again. Okay? Not use the 1 again. Monday, and it will be the Tuesday. Okay? And case 4. You can use simply. Case 4. Say Wednesday. I hope you all understand the hierarchy, right? Like that you can write anything. That means based on one single expression, one of the expressions based on CH, you can execute the n number of cases. You have to understand what is the need of the break and switch and all. I think we already knows that reserved words, right? Switch is one reserved word, break is one reserved word, if is one reserved word, default is a one reserved word. That means you are not allowed to use it as a variable names. At the time of variable declaration, we already seen that. But here I also use the class name as a switch, but I am using the capital S here. It will be the camel case, right? Here you am using the switch. This switch is different, this switch is different. Okay? It is the thing. That means reservoirs you are not using as a variable names or the class names, but you are not allowed to use. If you are use it, then it will return the error. Okay, I hope the switch case also you understand the thing, right? This is all about the thing. If you have any doubts, you can ping in the chat box, or else you can unmute and ask the questions, right? Or else, okay. In the next class, we will discuss with the loops and all. It's up to you. You have any doubts in this today's session? You can just chat it on the box. It will be the fine, right? Clear.